Hello and welcome to SQA Higher Maths, Applying Differential Calculus. We are looking at optimization. In the previous video, we looked at part A, and we showed that the total internal surface area of this open cuboid is equal to x squared plus 432 over x. Okay, so we're going to have a look at part B now. Find the dimensions of the tray using the least amount of wood. So basically, whichever company are making these trays, obviously they want to make as much profit as physically possible. So what they are going to do is try and use the least amount of wood to make a tray that always has a volume of 108 cubic centimeters. So if they can do that, they'll use as little amount of wood as possible to make each tray, meaning they won't need to buy as much wood in the long run, meaning they can make more profit. Okay, so companies do use this kind of thing in real life. Maybe not for making a tray like this, but they do use it to optimize their profit levels. So I have an area of x squared plus 432 over x. Find the dimensions of the tray using the least amount of wood. So the least amount, so we're looking for the minimum amount of wood. So we're just going to use our skills from earlier in the course, and we are just going to find the minimum turning point, because that will give the value of x, which will use the least amount of wood to make that tray. So basically, we're going to find, like I said, we're going to find the minimum turning point. So the area was x squared plus 432 over x. So get it into a format that we can differentiate. So rather than 432 over x, right, 432 multiplied by x to the power negative 1. Now we're going to differentiate. So power to the front, reduce the power by 1 each time. And I'm just going to rewrite this as 2x minus 432 over x squared. Okay, make our statement. Stationary points occur when dA dx equals 0. We are looking for a minimum. How do I know that? Because in the question it said the least amount of wood. So we need to solve this. So how we're going to solve this? So we have this equal to 0. What I'd like to do is to eliminate any denominator here. So because the denominator is x squared, I'm going to multiply all three of these terms. I'm going to multiply 2x by x squared, which will be 2x cubed. I'm going to multiply 432 over x squared by x squared. And what will happen there, if we do that, if we have an x squared on the top and on the bottom, they're going to cancel out, and we're going to be left with 432. And 0 multiplied by x squared is just 0. So that stays the same. So now we're solving 2x cubed minus 432 equals 0. So if it was a quadratic, I'd be looking to maybe complete the square or factorize like we normally would, but it's a cubic. So to solve a cubic, I would get the x cubed term on its own and then cube root. So 2x cubed equals 432. Divide both sides by 2 and then take the cube root of 216, which is 6. So we've found the value of x. There's only one value that's come out there, so we don't need to do too much more work. And because we're looking for a minimum value, we're looking for the value of x, which gives the least amount. We know that this should be coming out as a minimum on our nature table. So the fact that it has done means that we've probably got the question right. In fact, we have got the question right, but if you were doing it and it came out like that, you should be encouraged by that. So I've got dA dx, got x, so I'm looking just before and just after 6, so I can take 5 and 7 here. So if we substitute 5 in, just substitute into a calculator, guys, we'll get a negative value. Substituting 6 here, we'll get 0. And when we substitute 7 into here, we get a positive value. So this shows that the minimum surface area occurs when x equals 6. Now, have we actually answered the question? Does it ask for the value of x? No, it doesn't. It asks for the dimensions of the tray using the least amount of wood. So we know the base is x, so the base is x by x, so the length will be 6, the width will be 6, and the height was 108 over x squared from earlier on in the question, from part A. So the height will be 108 over 6 squared, which is 3 centimeters.